It's easier to start it. I've integrated OS script in our layout here too, and we try to make it as easy as possible to start with OS script. So we have, overall we have, if you don't have a presentation, you have to either compile it on your own, if you are a member of the Open Access Coalition, or you get a pre-compiled version ready to use for Red Hat Enterprise Linux 5. But if you have a new computer and try to run Red Hat Enterprise Linux 5, you get into trouble because the newest screen driver will not work or everything else. So a lot of setup had to be made to really get it run it. To reduce this fault, we have integrated the Open Access into our layout editor, and the installation is reduced on a minimum. So we have overall 20 packages ready to use for every Linux system, for every Linux distribution, for Windows. We have a package for Mac, but Open Access is not supported on Mac, so you can't run it on our Mac tools, but all other packages it is included. To start with this, you just need to download the package for your operating system, the first click. The second click is to install the package. The third click is you start it. And if you are has the editor open, you load your favorite script, pressing execute, and have the result. So you can reduce the whole installation. Normally, if you look at the tutorial how to install Open Access, they expect 1 week to get it up running. You can reduce it to 5 minutes. This script we have is very simple. You start having a point array, adding 3 points, and calculates the area of it. So it's a very easy starting script for Open Access.
Hello, in this presentation I would like to show you scripting a environment with OS script. Before we start, let's have a look on why we should use scripting. If you ask Google, you may find something like this. The major point is it is easy to learn and use. If we have a look on the Open Access script training tutorial, we find something like this. Preparation required 1 week, so it seems not to be extremely easy to start with. With our layout editor tool, we try to make this setup as convenient as possible. We provide ready-to-use packages for all major Linux systems, Mac systems as well Windows systems. Most of the packages include Open Access script. Just packages like for the Mac operating system does not support Open Access, as Open Access is not supported on this operating system. The setup is extremely simple. Download the package from our web page, install it, and execute it. Then you will have an environment like this, and you can easily start with your first script. Open the integrated text editor, open your file, and press the execute button, and you see the result. This example is extremely simple. It just creates a point array in Open Access, adds 3 points of it, and displays the area of the resulting triangle. Let's continue with the second example, this time written in Ruby. Here it is. The first line will import the Open Access script module into Ruby. The second line will avoid the prefix OA to any Open Access command. Without this line, the prefix had to be added in front of any Open Access command like this one. As any Ruby Open Access command starts with a OA, it's obvious and we don't need this prefix, and we just can remove it. So next, some setups come. The library definition is loaded. Just try to find the library. If it's not existing, the file path will be created and the library will be created. And here's the main part of the Open Access script begins. So the design is opened with this line. The library, cell name, view name, view type is open into the write modus. The design block, the major block of the design is created. These two lines will create a rectangle. First the box is defined and then the rectangle is added to layer 9 with property 0. This block of commands will add a polygon to the design. Point array is created with 3 points are appended, and a polygon is added on layer 11 with properties null 0. Then the design is saved and a completion method is shown. So let's try if this works. It works. The strip completed, but did it what we want to like to? To validate that, I've created further example, this time written in Python. Here it is. The first line of the script are very similar to the previous script written in Ruby. This line will import the OpenAccess script module. This line will remove the requirement of the OA prefix to any OpenAccess script command. Some variable setup, open the library definition files, try to find the library, error handling in case the library is not found, and here the first line is different to the previous script. We open the design not in write mode but in the read. If the design does not exist, some error messages will be printed, and the core validation check is made in this loop. A loop is done over any shape in the view. Boxes and polygons are counted, the result is printed to screen. Let's try if this script works. So we press on the execute button. And the result, we have one box and one polygon in the design. So the previous Ruby script seems to work correctly. To write your own validation script for any script you want to create, it's not very convenient. So we have a more convenient feature to validate your script in our tool. One feature to validate the script is a OA dump feature. We have it here in the menu. We open it, open dump view, choose our design, and we get an output. So we review this view of our design. Type mask layout as a bounding box of this contains a rectangle on layer 9 with property 0, contains a polygon on layer 11 with property 0. So it seems to do what it does. This way to validation may be more convenient than the previous one, but a visual review would in our case the most efficient way. Of course, we can also do it with our tool. We go into the layout editor, go on open access, open view, don't save it, view, open, choose our design and open it. And here it is. We have a rectangle and a triangle. We can review its coordinates, and they seem to be exactly what we would like to expect. OpenAccess script is an extension module to access OpenAccess databases, but is not a powerful editing tool. So, for example, if we would like to merge these two shapes into a single shape, we can't do it with OpenAccess. In the previous presentation we already heard something about ORXPOP. So, I would like to show you how this extension module can be used to merge these two shapes. Here the example list. The first of this script is identical to the previous one. The library will be opened, a error message will be shown if it's not can be opened, a box is created, polygon is created, the design is shaped. Now the new module ORXPOP will come into the script. I import it, remove the requirement of the prefix, define a feature set A and a feature set B, perform a loop over all shapes of the design, add all rectangles to set A and all polygons to set B. The Boolean operation is performed in this line. It's simple A plus B. The resulting polygons are returned here, and a loop over all point arrays returned by the Boolean operation is here. So one tricky thing with the ORX is POP extension is that the resulting polygons will have identical points at the beginning and at the end. But OpenAccess don't like these kind of polygons, so we have to remove the last point of the point array. This is done in this line. Afterwards, the resulting polygon with the cut away last point of the point array is added on a new layer, this time layer 10, property 0, to the design. Design is saved and closed. So, I would like to execute this script to show that it works, but I can't do it, because here I'm on a Windows system using Python 3.5. Our Xpop did not support this combination. The script will work with all our Linux packages correctly, but on this operation it will not. So this shows another important point of using scripting. It is recommended to use the version of Python, Ruby you have natively installed on your Linux systems, because on this system version you will have all other modules available and can use it without further setup. To show you the merge, I prepared a further script for you. This script will use the scripting module of our own layout editor tool. Here it is. The first lines of the script are identical to the previous one. File is opened, the block is created, polygon is created, design is saved. And from here our layout script module is loaded. The view, OpenAccess view, is loaded into our design. All shapes are selected and the merge feature is called. Afterwards the design is stored back to the OpenAccess database. You can also store it to a GDS file, DXF file, or all of the other design formats supported by our tool. So let's try this. Press execute and we get the result. This script is completed. Let's have a look on the design if the merge feature went through. So, don't save that. Open it here and press OK. And here it is. We have just a single shape. Two shapes were merged. The script will store the data to the disk and reload it with our tool. This might not be the most elegant way to perform the boolean operation. So, to avoid this storage, I've prepared a further example for you. So, the beginning of the example is similar to the previous one. The box is created, polygon is created, saved to design. And now the additional library or X layout script is loaded. This script provides conversion features between OpenAccess script and the layout script module. So once more the design is loaded from the OpenAccess database, but this time a polygon is created from the previous existing polygon P and a box is created of the box we have defined previously in the script. So no further load from the disk is required. Both shapes are added to layer 10. Layer 10 is selected and selected shapes are merged. Let's try this script. It is completed and let us view if it is processed correctly. So, and we see once more the merged shapes. If you are new to a scripting language, it can be hard to look up any command you need in the manual. The layout editor has built in a feature called macro recording, which will record any user interaction on the graphical user interface to a macro language. You may know a similar feature from some Office tools. It is simple to use. I will show you how it works. You go into the macros menu, select macro recording, and from now on any command you do on the user interface will be recorded. So I go to select all, utilities, shape utilities, modify corners, said I would like to comfort only sharp angles, comfort, choose message B and select a value of 0.1 micron, means 100 nanometers, and press OK. So you see the sharp angles are cut away. We go on macros again, select stop macro recording, we will get a resulting macro. The macro recording is done in the built-in scripting language C++. We can easily transfer it to the Python scripting interface. So you see the command com for select, value of 100 nanometers, 1 is a method, and 14 is a keyword for the angles which should be comfort. So this is similar to this line. I already inserted it before, so we not need just to uncomment it, just the message we chosen. Everything else is the same, and we can execute it. It will be completed and review it at further time. And here it is. You have the resulted merge polygon with chamfered edges as one single script. All scripts you have seen so far was handled in the same way. You execute the script and do a validation. Of course, we can also merge these two steps. I've prepared an example for this as well. So here it is. This time it's written in the built-in C++ scripting language, and you see the main C++ feature here. This line will execute the script. This time the previous example. This line will open the result layout editor, and also two DRC rule checks are made. So let's execute this script. Here it is. The Python script is completed. The DRC check is done. The first check results in no errors, and the second check will result in a single error. So here's the result. We have the merge polygon as we had before, and also DRC check. We can also display more detailed the DRC violation. This time it was a minimum dimension violation. It did not pass the test. To make the use of this executing macro more convenient, we can add it to the menu. To do so, we just need to store it to the correct place. So go to the save it to the macro folder of your layout installation. It is right here. It should be placed in the text area macros under utilities, and we just need to enter a name and store it. After reopening the editor, we will have located the macro in the utilities menu of the text editors. Just need to press execute, the script will execute, and the DRC test performed. This was the last example I've prepared for you today. I hope anyone was able to see how efficient scripting can be used. If you need more information, please also have a look on our website layouteditor.net or contact me. Thank you for your attention.
So we have the possibility to combine everything, scripting in Python, scripting in Ruby, scripting is our interface, and so we don't not fixed on one programming language. So you have a variety. If you have a colleague focus on Ruby, you can combine this with a Python script and did not care about which language you prefer. So this is what I want to present on our tool, and I hope that you have learned a little bit about open access.
Questions? I've got one. Can you describe your user base? What areas people are working in that are your customers?
My customers usually make special things like superconductivity, integrated circuits, microwave in our area, microwave integrated circuits, or microwave printed circuit boards, nanoelectronics. Everything is not standard for on silicon on electronics. Everything is apart from that. My tool is used. The customer base is about 3,000 licensed customers, and at least 10 times more customers use as a viewer. The tool can be freely used as a viewer as long as you don't save any design data.
Do you have any plan to do the source part, the schematic editor, or a schematic viewer, headless viewer?
Schematic viewer is included. I just did not display it, so we have the schematic in it.
Oh, okay. I'm always doing it as a layout editor. that need this.
The name is layout editor.
Yeah.
So it is really OA
Yeah.
viewer.
And now you can say you've met the entire company.
Yeah, it used to be fully free. I believe it was 2009, 2010.
Yeah, I started 2009 to make a commercial. Before I was a spare time project. And in 2009 it was split to a free version as a viewer and a commercial version if you want to learn to edit designs.
All right, but that concludes our presentation. I hope you'll stay around and watch the demos in the back and the ILS demonstration. And there's some flash drives and DVDs over there with the demos in case you don't have time. And there's even some free earbuds so you can watch them on the plane on the way home.